Hello, boys and girls. Welcome back to our class. Today, we're going to be learning about perpendicular and parallel lines. Our learning objectives are I can define and identify perpendicular lines, and I can define and identify parallel lines. I know that the rectangle has right angles because if you put the two segments in one of the corners, makes a perfect corner. That means it has a horizontal line and a vertical line that makes a right angle, a perfect corner. And why is that important? Because today we're learning about perpendicular lines. And it happens that a perpendicular line is the same or equal or equivalent to a right angle. So that means that this right angle is going to be a perpendicular line. A set of perpendicular lines. Let's see it in another example. Let's look at these lines. If you notice, if I put a square here, you can see that the square fits perfectly in this corner. Therefore, I can tell that line AB is perpendicular with line CD. So let's write a sentence about that. Lines A and B, which is this one, and lines C and D, which is this one here, meet at right angles. So I can tell then that line AB is perpendicular to line CD. In this other example, I notice that I cannot fit perfectly the square into this angle. I notice that is the angle that is greater than the right angle. If I try to make it fit in this other angle, I notice that one of the arms of the angle goes under the square. So that's showing me that it's a smaller angle than the right angle. And if I try to fit this, which is the right angle, if you see I can fit it right in the corner of the square, I notice that I cannot fit this angle in any of the angles inside these two lines. So I can tell that lines EF and lines GH do not meet at right angles. Therefore, I can tell at the same time that line EF is not perpendicular to line GH. We can find perpendicular lines all around us. For example, in the stairs, if you can see, we can fit here a right angle, and you can notice because you have this little square in the corner that fits perfectly. We can find right angles in a football field, and every corner that you see and you can fit a square perfectly, that's a perpendicular line. Right angle makes a perpendicular line. In the windows too, we can find right angles, which is the same as perpendicular lines. We can find them too in every place. Like maybe the floor, the tiles on your floor, where you can find the squares or fit the squares in the corners of each tile. So that makes perpendicular lines. Or in the flag, we can find some perpendicular lines. When we move this around, we can fit them in the corners too. Let's find the perpendicular lines of which of these shapes. We have 4 shapes here, and we're going to try to find the ones that have perpendicular lines. So I'm going to use a square, and if I can fit it perfectly in the corner here, see, it's touching both sides of the square, I go to the other side and the same happens, then I can tell that this is a perpendicular line, So I can mark it, telling these are perpendicular lines. If I try to do the same in number 2, I notice that this side is greater than a perpendicular lines. And if I move it to this side, this is going to be smaller because one of the arms goes under the square. So these are not perpendicular lines. Let me check on this one. Sometimes we may think these are not because they are on the side. We can rotate it around the paper so we can notice that makes perfect corners. So we have here some perpendicular lines because I can fit perfectly the square in all of the angles. So this is going to be perpendicular lines. If I try to do the same in this shape, I can see that one of them goes under the square, so that's not perpendicular lines. If I move it to the next corner, I can notice this one is greater than perpendicular lines. So this is not a set of perpendicular lines. We can find perpendicular lines inside geometric shapes. For example, this triangle. If I fit my square, I can notice that it's forming one set of perpendicular lines. Now I'm going to write a sentence about that, and I'm going to tell that line AB, so let me write it down, line AB is perpendicular to line, and in this case it's going to be BC. So I just wrote a sentence explaining these two lines. Now let me go to the next shape, and I can notice, wow, this one has a couple of sets of perpendicular lines. If you notice here, you can see that the squares up here, they're building up already the perpendicular lines because I can fit here a square. You notice this is a square, and I can fit another one here. So this shape has two sets of perpendicular lines. So I can fit in this corner, I can fit the square if you notice. Or in the other side, I can fit it too here in this side. So this one has two sets of perpendicular lines. I can mark it here too. I can mark the square here. So you can see how is it making perpendicular lines. So in this one, I can write a different sentence, like I can write this shape has two sets of perpendicular lines. And I can explain which ones there are. ZW is perpendicular to ZY, or I can write that ZY is perpendicular to YX. Let's explain parallel lines. Parallel lines are a set of lines that keep the same distance or equal distance from each other. They'll never meet. If you notice, they don't get closer or farther from each other. They always keep the same distance. These lines could be in different directions. The important thing is that they never get closer or farther apart from each other. Let's use this rectangle to find some parallel lines. If you notice, I can put a set of parallel lines here on each of the sides, and these lines are keeping the same distance from each other, which makes them parallel. I can put another set of parallel lines in the opposite sides of the rectangle. For example, here and here. If you notice, this is another set of parallel lines. They don't get closer or farther apart from themselves. So I can tell that this rectangle has two sets of parallel lines, the blue set and the orange set. In this example, you can notice that I have line AB and line CD. And if you look at the grid below, you can notice that they have a distance of 2 squares all the time. They're not getting closer, they're not getting farther. So I can tell then that lines A and B and lines C and D are parallel lines. Now something interesting I want you to notice that is how to remember their name is to look at the word parallel. If you look at the word parallel, the two L's are making parallel lines. They're keeping the same distance. So I remember that parallel lines have within the word the two parallel lines. Now the same sentence, I can tell it a little bit different, which could be line AB is parallel to line CD. So these are two sentences you can use to describe parallel lines. Let's look at another example. In this set of lines, you can notice that they are parallel. How do I know? Because when I place the rectangle inside or between the two lines, you can notice that they keep the same distance. They're not getting closer to each other and they're not getting separated from each other. Here they are counting like you have two diagonal squares and you can count them here too, 1 and 2, which shows me they are not getting closer or farther apart. So I can describe again the lines by saying that line EF is parallel to line GH. And the same as the one we did before, I can tell the same sentence telling that lines EF and lines GH are parallel lines. Now in this exercise, we're going to try to identify parallel lines, and we're going to place a check in the ones that are showing parallel lines. So let's look at the first ones. I notice that in the top, they have 3 squares distance, and in the bottom, they have less than 2 squares distance. So I'm sure this is not parallel lines. If I prolong the lines, if I put the sticks on top, I'm going to notice that if they keep on going, eventually they're going to meet. See how they're meeting down here? If I follow the lines on the top, they're going to meet. So they're not parallel lines. Let me do the one on the number 2. If I do exercise number 2, I can notice they keep the same distance. And I notice because I can count 3 squares in between. That's showing me that they are not getting closer. So these are going to be parallel lines. Let's look at example number 3. Even though they are in diagonal, I notice they have 1 square distance. They isn't a diagonal, but still 1 square. I can even count it here, 1 square, 1 square, 1 square. And if I prolong the lines, I can notice that they keep the same distance. They're not getting closer. So they seem to be parallel lines. And the last one, they're kind of confusing a little bit, but I can notice this is the distance. It's like a diagonal of 2, and this is not keeping it. Anyways, I can try prolonging the lines with this stitch. And eventually, if you notice, they're getting closer and closer. Let me just move it again. Okay, that's better. And if you notice now, these two sides are getting closer. If I prolong it even more, I move this one a little bit more, and this one, eventually they're touching now. So these are not parallel lines. Let's do the last example using some shapes. To find parallel lines in figures, you have to remember they have to be opposite, like A and B, line A and B, and C and D, I can notice they are parallel. So I can write the sentence explaining that. So let's write line AB is parallel to line CD. So line AB is parallel to line CD. Or I can tell I have another set here in the sides. See, now I have AC and BD. I can write it like this. Lines AC and BD are parallel. Now, if you notice this shape, we're going to have this almost the same, right? I can see that FG, the line FG, and IH are parallel. So I only have one set here. If I try to find another set, I'm going to notice that EF and GH, okay, let me just place it back, they're not parallel because if you notice, they're getting closer together and they're separated in this side. So this one only has one set, which is going to be FG and IH. We can find parallel lines in real life objects. For example, in the case of a keyboard, we can find parallel lines. If you notice, the little rectangle moves and the lines are not getting closer together. You can find more in the black keys too. In a bookshelf or in a shelf, you can find different sets of parallel lines. In the escalator, if you look carefully, you'll find more than one set. In the fence, we can find more parallel lines. Those lines are keeping the same distance from each other. And finally, in these trees, if you look at the trunks, you can see that they are keeping the same distance too. So look around, and you may find a lot of parallel lines in your classroom, at your home, or when you're walking home.